Hey there, Mr. Sutton here with the Pre-Cal Honors 4-2 Part 1 homework solutions on compound interest. For this problem, Bill and Stacy deposit $800 in a savings account earning 13% interest compounded annually. They want to use the money in an account to go on a trip in 2 years. How much can they spend? All right, so for this one, since we're not compounding continuously, we can use PB to the T. And since we're just compounding once a year, compounding annually, we can just add the interest rate to 1 to get a growth factor of 1.13. And then our principal is 800, so 800 times 1.13 raised to the second power, because 2 years is what we're looking at here. Now for the calculator. And that's going to come out to exactly $1,021.52. For this problem, we have $82,000 invested in a 9% account, compounded daily. We want to know how much money is going to be in the account after 6 years. Since we're compounding more than once a year, we're going to start with the PB to the T formula, but then we're going to have to upgrade the B value. So we're going to do 1 plus the interest rate of 0.09 divided by, let's see, daily is 365, all raised to the 365th power. So this is getting our special B value for compounding 365 times a year. And let's plug that in the calculator. So I'm going to plug all of this in, and I'm also going to store this. I pressed the stow button to store it as alpha A, just so I can pull up this crazy decimal I get right here whenever I need it. But I'm going to round it off for the paper part of this. That's 1.0942. But really, I'm going to be using that decimal in my calculator now. So now I'm going to do 82,000 times this right here, and that'll be raised to the 6th power for 6 years. So on my calculator, I'm doing 82,000 times A, because I've stored this decimal here as A, raising A to the 6th power, and I get $140,703.20. On this problem, we want to know how much money you'll have if you invest $52,100 at 11% interest compounded monthly for 13 years. Since we're not compounding continuously, we'll use PB to the T, and then our principal, that'll be $52,100. For the B value, we need to use our formula of 1 plus R over K to the K, since we're compounding more than once a year. So this is going to end up being B equals 0.11 for 11%, divided by the K value of 12 for monthly, raised to the 12th power. And let's do that on the calculator. And while I'm calculating this on the calculator, I'm also going to press the store button and alpha A. That's what this arrow A business is about. So I'm going to store this decimal of 1.1157 as A. I'm going to write the rounded off version here, but I'm actually going to use the true value when I go ahead and run the numbers later on here. Okay, so what numbers am I running? Well, I've got 52,100, my principal, times this, or the true version of this, raised to the 13th power for 13 years. Let me go ahead and run that now. So I've got 52,100, and then I'm going to do alpha A, and that's going to bring up this decimal here. Now I can just raise that to the 13th power, and I get the most accurate possible answer of $216,296.59. For this problem, we have Candace putting $500 in an account for school expenses. The account's earning 8% interest compounded daily. How much is in the account after 7 years? Since we're not compounding continuously, we can use PB to the T. But since we're compounding more than once a year, daily, we need to do B equals 1 plus R over K to the K power, that special formula. So that's going to be 1 plus the interest rate of 0.08 divided by the K value of 365 for daily, raised to the power of 365. So I've entered this in my calculator, and I pressed store and then alpha A, so I can store this decimal value in the calculator as A. Let me just write out the rounded off version, 1.0833, but I'm going to use the real value in my calculator. So now I have to do 500 times the real value of this, raised to the 7th power. To do that on the calculator, I've got 500 times, and then I'll do alpha A, and that immediately gives me that decimal that I just came up with a second ago, and then I'm raising that to the 7th power, giving me a final value of $875.28. For this problem, I want to find the amount of money I'll have if I invest $30,828 at 2% interest compounded monthly for 11 years. Since I'm compounding more than once a year, I'm going to need to do PB to the T, and then I'm going to have to do my special B formula of 1 plus R over K to the K. So in this case, that's going to be 1 plus 0.02 for 2%, divided by the K value of 12, because it's monthly, and raised to the power of 12. Plugging that into my calculator and storing that value as A so that I can call it up whenever I need it, I get 1.0202 if I round that off. So now I'm going to do 30,828, that's my P value, times this B value, although I'm going to use the real thing on the calculator, raised to the 11th power. So here's what I'm actually entering on my calculator, 30,828 times A, where I've stored that entire value without any rounding, raised to the 11th power. And that's going to be $38,407.02. For this problem, I want to find the money I'll have if I invest $6,987 at 13% interest compounded quarterly for 3 years. That's a really good interest rate. Okay, let's break out our formula here. Since we're compounding not continuously, but more than once a year, I'm going to start with PB to the T, and then I'm going to get my special B formula of 1 plus R over K to the K. So in this case, I've got 1 plus 0.13 for 13%, divided by a K value of 4, because this is quarterly, raised to the 4th power. Let's do that on the calculator. So plugging this in the calculator, I'm going to also press the store button, and that's what this little arrow is, and store that as A, or whatever letter you want. That ensures that I can keep this crazy decimal around in case I need to use it later, which I will. So that's going to come out to 1.1365 if you round that off to 4 decimals. But again, I'm going to use the real whole thing on the calculator. So now I'm going to have to do 6,987, that's my principal, times this, or the rounded off version of this, raised to the 3rd power, because we're doing this for 3 years. Back on my calculator, I'm going to do 6,987, and then I'm going to do alpha A. That brings back this value here, which I am now going to raise to the 3rd power, and that comes out to $10,255.85. On this problem, Jing's putting $700 into an account for school expenses. The account earns 10% interest compounded annually. We want to know how much is in the account after 8 years. So for this one, since I'm not compounding continuously, I'll just use PB to the T. And since I'm only compounding once a year, annually, I can just add the interest rate to 1 to get my B value. So that's going to be a principal of 700 times the B value of 1.10 raised to the T value of 8. And now plugging that in my calculator, that comes out to $1,500.51. For this problem, we want to know how much money we'll have if we invest $12,600 at 4% interest compounded daily for 16 years. So I'll start with PB to the T, since I'm not compounding continuously. However, since I'm compounding more than once a year, daily in fact, I need to do my special B formula of 1 plus R over K to the K power. So in this case, I've got 1 plus the 0.04 interest rate here, divided by a K value of 365, because we're doing this daily, all raised to the power of 365. Let me do this on the calculator. And while I'm doing this, I'm also going to press the store button to give me this arrow here, and then alpha A, so I can store this big decimal here as just A. So that's 1.0408 if I round it off. But I am actually going to use the true value, which I've stored as A on my calculator. Next, I've got 12,600, that's my principal, times this growth factor raised to the 16th power. And back to the calculator for that. So 12,600, and then I'm going to do alpha A to pull back my growth factor, and then raise that to the power of 16, which gives me $23,894.82. For this problem, we have Garrett opening a savings account with $5,000 as the principal. Accounts earning 2% interest compounded weekly. What's the balance after 12 years? So we'll use PB to the T because we're not compounding continuously, but because we're compounding more than once a year, we need to use the B equals 1 plus R over K to the K power formula. So we're going to do 1 plus the interest rate of 0.02 divided by 52 for the K value, because this is weekly, 52 weeks in a year, raised to the power of 52. So I've entered this in my calculator, and I also did store and then alpha A right here so that I can store this decimal as A and use it whenever I need to. So that's going to be a B value of 1.0202 if we round off, and then I'll use the actual value when it comes time to use the calculator. So going back now, we've got 5,000 times my B value raised to the 12th power. And back to the calculator here, that's going to be 5,000 times, now I'm going to do alpha and then A, alpha A, and that gives me my B value right away. Maybe I should have done alpha B, but whatever. Alpha A is where I stored this. And then I'll raise that to the 12th power to get a grand total of $6,355.95. For number 10, we're investing $3,600 at 8% compounded annually for 9 years. Since we're not doing continuous compounding, we've got PB to the T. And since we're only doing it annually, we don't really need to use the compounding formula for this. We can just use a B value of 1.08, and then we have the principal of $3,600 and a time of 9 to raise that B value to. So if I plug that in the calculator, I get a grand total of $7,196.42.